Well, we'll see what I have to do to get all the way up to Galois theory proper. But we need some more definitions. Like a right coset for a subgroup H of G looks like the subgroup H multiplied on the right by a single element X. That's the set of all elements in H times X. That generates the coset. And a left coset is the set of all little x times H. So that you'll do XH for all H and H. Little h and big H. So the right coset is the side that the element is on, that if you multiply on the right, H on the right by X, call it a right coset. If you multiply H on the left by X, then it's called a left coset. And X, of course, is an element from, must be an element from G here. Although I didn't write it, I should have. The index of H and G, often written with like the absolute value symbol and G colon H. Or some people use IND with a subscript of G of H. And either way, you're finding the index of H and G, and that's the number of distinct left cosets. So we can talk about the relation between the number of left and right cosets, right? But right now, it'll be defined as the index of H and G is the number of distinct cosets of left cosets for H. All right, a normal or an invariant subgroup. Normal is the typical term for that. All right, so H is a subgroup of G, and if the left cosets XH equals the right cosets HX, for all elements X and G, if the left coset of a particular element equals the right coset of particular elements, then H is normal in G. You can write it backwards like this. You just reverse the triangle. So H is normal in G if all the left cosets for a particular element in G, they match the right cosets for that particular element in G. All right, a factor or a quotient group, if H is normal in G, then G mod H is the set of distinct cosets. So if H is normal in G, the set of distinct cosets, the multiplication is defined by the left coset XH times the left coset YH. You multiply XY and multiply that by H. So the coset of XH times the coset of YH, that is equal to XYH. That's how you define multiplication. And G mod H, you let X range over all of G to generate the distinct cosets XH for the factor group or the quotient group. So what do we talk about? We talked about right and left cosets, the index, normal or invariant subgroup, and factor or quotient group. These are all pretty big subjects, and I may take some time on them later and insert videos. But for now, we're just going to keep on moving in a particular direction towards the Galois stuff.